Hello, I'm Cora Watson,
And I'm Craig Harris.
and today we are going to present and discuss our design tool idea and its proposed implementation into game design. We have chosen to focus our area of study on the difficulty mechanic. Our tool hones in on the dynamic difficulty adjustment system of this mechanic, where a game's AI will adjust in difficulty according to how the player is doing. Our system will be exclusive to the first-person and third-person shooter genre, as we believe this to be the area lacking in the provision of teaching the player skills appropriately.
As you can see on the right hand side, we have created a set of scales for each weapon available in the game. These scales are a compilation of different factors that are taken into consideration in order to work out a score that the player has achieved from completion of a previous game zone. Simply put, these are the score boundaries for each weapon that will be averaged together at the end of a zone in order to score the player overall. These coloured sections display the range of scores that the player can achieve for each aspect of their performance with a weapon. For example, if a player was to use all 5 weapons in one zone, that's all of these 5, and kill only one enemy with each, but they have used 7 shots with the pistol, and they have used 30 shots with a HMG, we can see that changing these numbers affects not only the accuracy percentage, but also the score achieved with this weapon in the zone. Also, if we were hypothetically to change the number of enemies killed using the weapon, this also changes the score. This is because the score is calculated by the number of bullets fired divided by the number of enemies killed. When we have this score, we can filter it into the ranges that we have previously set up and find the corresponding performance score, which is out of 100. For more efficiency, we have added this code which does the comparison for us and also rounds it up. The accuracy rating is a lot simpler. It is just the percentage of shots hit compared to the number of shots fired, and being a percentage, it is of course out of 100. Moving further down, we find the time section of the tool. Here we can simply enter the time in which the player completed the zone, and like the previous section, it will automatically compare it with the score range that we can see on the right hand side. So hypothetically, if the player takes 300 seconds to complete the zone, we automatically get the corresponding score value for that time, again out of 100. Below this, we can see where all of these sections are brought together. We have a table of the game factors that we have previously discussed, and what score they are currently on as a result of the previous zone performance. These scores are all averaged together in order to get a score value for the complete performance for previous rounds, again out of 100. The final section is looking forward onto the next zone. As we can see on sheet 2, these are the default values for each enemy type, for each zone, for each difficulty. These can be referred to any time in case we need to check any values. Going back to sheet 1, we can see how the score rating for the player has increased these numbers already. This is due to the multipliers that have been set up to alter the game difficulty. As you can see in this table of multipliers, the different ranges of numbers correspond to how much the base numbers of the enemy stats are increased. The better the player performs in the previous zone, the more difficult the next zone will be, on top of the natural difficulty curves that comes with the game. As you can see, if we change the values of time taken to 60 seconds and the weapon scores to a perfect round, you can see that the enemy stats are increased even greater than before. This is to not only match with the player's skill level, but also to push their skill even further, so that by the end of the level, they are ready for the next step up.
We are going to apply this tool to the game Max Payne 3. Now in the write-up, we have explicitly made this tool to coincide with first-person shooters. However, we have also explained that depending on the type of third-person shooter, it can be applied to them as well. Max Payne fits the criteria perfectly because it has a mode called Score Attack that already has some functionality that analyzes the player's progress, but instead rewards them with medals rather than increased difficulty. It looks for the player's completion time and accuracy to determine the points given and subsequent medal. As well as this, it has various difficulties, which change the default number of enemies spawned. Furthermore, like first-person shooters, it has areas of combat and no combat, and Max Payne has continuous action, so the zoning method we discussed will apply even more. Now that we've analysed the gameplay, all we then need to do is slot the relevant statistics into the rough table. As you can see, we have recorded all the necessary stats relevant to our tool, such as time, weapon used, bullets fired, etc. All we then need to do after that is then put it into our tool. Okay, so all we now need to do is to plug those values that we got from the game in the then put into the rough table into the proper tool. And obviously, if this was implemented into a game engine to record the metrical data, then it would automatically do this, but obviously it's not, so we have to plug the data in ourselves. So as we can see, as we know, five enemies were killed, 5 shots hit, and the bullets that were fired was 5, so that's a perfect score. So the weapon score is 100, because that looks at enemies killed, the shots fired, and the bullets that were fired, and the accuracy is 100% because we hit every enemy out of every bullet that we shot. And as I said, and as Craig explained before, it puts it into the score obtained and gives you the level equivalent, and so does the accuracy level and the equivalent percentage to that accuracy. We move on to stage 2 now, which is the completion time. And if we just change this for a second so I can show you how it works. So the time taken we know to be 23 seconds, and if we just run back over to our Max Payne stats, we can see, yep, definitely 23 seconds. So if we plug 23 seconds into here, then we get a final time score of 100, and yeah, and the level equivalent is going to be 100, because if you look here, anything 60 seconds and less is going to be 100. It just needs to be mentioned that depending on what the developer wants, all these numbers are subject to change. So if they wanted to say 10 seconds or less was 100, and anything 100 seconds or above was a really bad score, they just need to plug those figures into here and it will give them a different level equivalent. But this is the way we've done it, so 23 seconds is a good score. So if you move on to stage 3 now, it analyzes the complete criteria, so the total average weapon score of the previous round, or of the first zone, the average weapon accuracy of this zone, and the time taken for the zone just completed. And as we said, perfect score for the round that's just happened, and this is the total score here, and all this cell does is round that up to the nearest 10. Obviously it's going to be 100. So in the final stage is taking a look at the skill range. So all that does now is takes this number, the rounded up number, complete number of how you performed in that zone, puts it into the skill range, and as you can see, we are 80 to 100, which is a grade A, and the multiplier is 1.8. Basically what happens now, if we go to sheet 2 and we look at the default values, let's work off easy mode just to keep things simple. Even though Max Payne was just played in hard mode, we're going to stick to easy mode for now. As you can see, in zone 1, actually no matter what difficulty it is, 5 enemies are spawned. So all we then do is look, grade A gives us a multiplier of 1.8. So in the next zone, which is zone 2, the default amount of enemies that are going to be spawned is 8. So then all this tool now does, if I just grab the calculator for a second, is that does 8 times by 1.8, which is the multiplier we just received for our good performance, and that gives us 14.4. and all this cell does is round that down back to 14, because you can't get zero point 0.4 of an enemy obviously. So we know that zone 2 is going to have 14 enemies in easy mode. And something just worth mentioning is that when it comes to the actual default enemies and the multipliers, the depending, for example, zone 1 we performed and got a 1.8 multiplier. That means 14 enemies are going to appear in zone 2, because that's default number 8 times by 1.8. Then if we perform badly, let's say we get a C grade in zone 2 that gives us a multiplier of 1.4, then all that's going to do is then times the default number, which is 12, by 1.4. So in zone 2 we are going to get 12 times by 1.4, and we are going to get 16 enemies in the next zone, which obviously you can't get 16.8 of an enemy, so that's going to give us 16. And that's basically the way it works.